Hello, I'm Brandon Williams, CEO and co-founder of CPLANE.ai, based in Silicon Valley, California. We're developers of the software platform for edge computing by implementing automated and intelligent orchestration. In this short video, I will describe how we have tackled the enormous complexity inherent in edge computing. Edge computing is a continuum of complexity. The early edge and IoT solutions just entering the market today are built largely on a hub-and-spoke model, that is, a device or sensor connected to a local gateway that sucks the data back to the public cloud or to a core data center. There's little doubt, however, that the future of autonomous cars, ubiquitous augmented reality, and automated delivery drones will require solving a great number of additional challenges. So on the right, you can see the end goal of actually delivering edge computing, and that is applications and services are consumed on demand with no human intervention. To do this, we'll have to replicate much of the self-service model common in public clouds, but at a massive scale at the edge. That is, a massively distributed cloud computing infrastructure. Nearly every vertical is anticipating massive change and opportunity for new services, new efficiencies, and a better world utilizing edge computing. But the continuum of complexity starts to become evident as you look at the incredible diversity of industries that will consume edge computing resources. Each one of these verticals has different compute requirements, different network topologies, and different application life cycles. And there's even variation among the companies within each vertical. Today, it's clear that one size will not fit all, and a great deal of variety, and therefore complexity, is inherent in the market opportunity for edge computing. Unless this complexity is overcome, the market will be stunted. I believe this is why there has been a slower than expected adoption of IoT solutions over the last several years. CPLANE.ai has had the privilege of being invited into numerous customer use cases where complexity is thought to be a formidable barrier. And I'll try to discuss some of these briefly as well as some of the challenges. In the first case, Intelligent Edge Compute, a global building systems company, wants to provide security, media content, safety, and maintenance monitoring services inside their customers' buildings. So an appliance would be installed in the building, and then a virtualized stack would remotely spin up the applications, run diagnostics on building systems like HVAC, conduct facial recognition on video feeds, and monitor all kinds of systems for fault and maintenance predictions. The challenge of deploying all these appliances in all of these locations is maintaining that kind of complex compute environment, how to maintain the application life cycles, and of course sending only the most critical data and alerts to the public cloud when necessary. The second case is a large public electric utility. They want to be able to deploy several million smart meters, essentially Raspberry Pi type devices, on residential homes. And they want to be able to create an app store so that residents can optimize the energy consumption and even predict maintenance issues with their home appliances. The challenge, of course, is how do you maintain millions of compute endpoints? And even more challenging, how do you deliver applications or OS updates over the existing wireless mesh network that's almost completely subscribed today? A third use case involves clouds on trains. A North American railway company wants to enhance their customers' experience. They want to monitor equipment on the trains and improve safety and security by having microclouds on board their trains. Having a self-regulating and self-healing cloud environment is paramount, as well as navigating the intermittent network connectivity as trains travel between stations. Clearly, dynamic networking and intelligent management are required. Lastly, I will mention industrial IoT, or Industry 4.0 as it's often called. Manufacturing and industrial processes are merging IT and OT systems. The DCNs and PLCs are becoming virtualized in many cases, which adds tremendous flexibility for upgrades and interoperability, but requires lots of automation and abstraction to make it manageable and reliable for the industrial end user. While these use cases all seem different, they actually point to the continuum of complexity that I described before. Because of these customer interactions, CPLANE.ai has been given a front row seat to the challenges of delivering reliable, scalable, and easy-to-consume edge computing. Perhaps most apparent is that the edge computing complexity overwhelms today's tools and the abilities of human management. Distributed devices makes networking complex, and the different use cases will drive a wide assortment of hardware, operating systems, and connectivity requirements. Simply stated, today's DevOps tools simply were not created for the hyper-distributed use case. But I ask you, how do you typically tackle a very difficult and complex problem? I suggest that you probably focus on two things. First, you agree on a set of facts and conditions that describe the situation. Let's call it the truth. Second, you break the problem down into smaller parts so that it's manageable. These are proven principles of distributed systems and distributed computing. And this is exactly how CPLANE.ai has tackled edge computing complexity. First, we have a single truth in a common information model. This information model is like a digital twin of your distributed computing environment. It captures a central understanding of the edge environment like topology, state, and configurations of physical and virtual systems. From the central truth, we can apply intelligent orchestration, that is, policy rules, workflow engine routines, service and device modeling, and an SDK for rapid customization. And then, from this sophisticated platform, we have built multiple controller solutions that each orchestrate a key portion of the edge computing domain: networking, application lifecycle, virtualization, whether it's VMs, containers, or bare metal, and of course, compute and devices, the hardware. By breaking the edge computing down in these domains, and by sophisticated abstraction of the underlying infrastructure, both physical and virtual, we can begin to deliver edge computing at scale. There are many details to delivering scalable and reliable edge computing that is easy to consume. Multi-domain orchestration provides all of the essential automation, intelligence, safeties, and simplifications for edge computing. Rapid and intelligent deployment of applications in the optimum location on compatible hardware with secure networking every time with no human configuration. This is the only way to deliver edge computing without hiring thousands of cloud IT engineers. Solving the complexity of edge computing has been our passion for the last several years. Today, the business back end on the right, like public clouds or enterprise data centers, are well understood. And much of the attention for the edge has focused on devices, things, sensors, and their management, security, and connectivity. But the real complexity of the intelligent edge has yet to be addressed. Multi-domain orchestration from an intelligent platform is the way forward. Networking orchestration, application orchestration, virtualization orchestration, and device orchestration, all by a single platform, CPLANE.ai. Thank you for taking a few minutes with me to learn more about the challenges of edge computing. Please check out our website at www.cplanei.com for more information. I'm Brandon Williams, and good day.